I've seen 491 before, and it had its share of issues, so we're going to try the layout this time, see if we can get all the geometry in. Take what we learned from last time and go again. Alright, so part metric, we're going to go on the top plane. Let's set up a couple of center lines just for reference. So vertical and infinite length, and horizontal and infinite length. And I missed the origin on that one, so we'll drag it back. Okay, not snapping for me, so we'll go to coincident. Alright, so the outside geometry, if we put that, let's see, I'm thinking I'll probably put the center point at this intersection and kind of build it out from there. So angle, a little bit of a step, a little bit of a chamfer, come back. And then for this side there will be a little ways up, a little more chamfer, and then come back. And that already takes care of the 12 millimeter, so we'll bring that up. Alright, so let's start putting some dimensions on this so that we can get it into reference. So I'm only going to do the half, so 90 on the width. 40 for reference back to the point. So and one of those angles back a little bit. Okay. Now we'll get some more dimensions on the chamfers, and hopefully this won't cross up too bad. All right, 15 millimeters. And then from the sides, 20 millimeters. Okay, for the other, and the way that moved, that always makes it suspect to be perpendicular. So we're going to check real quick. Get rid of that perpendicular reference. And it's also going to be 20 millimeters. And let's see, the 10 millimeters is from this point to this point. So basically that line. All right, so I don't want the angle. All right, the overall then, well, we got 20 for the overall. Okay, so from there to there, it's going to be a stack up. All right, so that gets the geometry in. And then this step was 35. All right, so starting to come into definition. Not parallel yet, so let's go ahead and add the parallel so I can put the 12 millimeter on it. And the 12 millimeter, nope, that's not gonna do it. It's not the thickness; it's at the end points. All right, so that gets the step, the web, the top. And then we have the two hole locations, well, 3 hole locations. So bottom one is 12 millimeter. Its location is 20 off of the center line. And height-wise, okay, so we have 22 there, just noticed 22, 12, and 10, that would be 22, so don't need to chase that one. And then 15 off of the base. All right, so that endpoint stayed. All right, center line, just for reference. And that one had 15 in 2 places, and then 13 from the leading edge. And that one can't really go 13, but we'll put it there. to its center point then. See, 90, 45. And then from this point back, also 13. So yeah, those holes intersect in the base. All right, so that web, oh, that one jumped. All right, so let's take the coincident off, and we'll reapply it there. Set the two to equal. Apply a dimension. And those are 8 millimeters, 4 places. Has a distance of 20. And across the holes, and then between the holes is 15. So based on that, nope, it's still gonna be notched out in that geometry. So, all right, so I only have the 2 center lines. So I want to make sure that that one doesn't participate, and then that is the axis that I'm going to mirror across, and that gives me my geometry. All right, so if I go Control 7, that'll give me the very base piece. All right, so features, extrude. Selected contour is the end region, and its thickness is 6 millimeters. Share the sketch and extrude, then the next region, and sure enough, it picked up that geometry. So, all right, total height is 40. I was just thinking how I want to deal with the other 6 millimeters, but we have the cut throughs. Extrude. I'm going to take this region, and let's go ahead and do the offset, or the surface face or plane. Bring it up, reverse the direction, change it to 6 millimeters, and go in. All right, so a little bit easier than last time. Took what I learned and made it a little bit better. Still, from a manufacturing standpoint, we need to do something about those. I mean, if they need to be there, that's one thing, but that's going to make for some interesting machining to get that geometry out. Okay, so let's go ahead and save it, P4-91, and we'll be on to the next. All right, so symmetry across the base. Again, from a manufacturing, if this is casting, well, even that's not structural. There needs to be a rib or something underneath this to help support it as the material is loaded, or whatever that that cylinder is doing. We can go ahead and build it as is, and then go with the modifications. So center line is well, we have symmetry across the front plane. So we'll go back into the metric. Don't need a vertical center line on this one so much, at least for reference. So infinite length, horizontal. Square off the corners. Step and back and step. Okay, so we'll go ahead and get some dimensions on this to get it started on scale. 100 by 102. Double check my lengths, make sure that there's not a stack up. And then 60. Okay, not sure what it grabbed there, so 60. And then the across the step is 50. All right. For the leg, then we'll go 12. And the pockets are 25. And looks like, what do we have? 15 from the edge. Just the center. Let's see, 22 places, so 20. And then its location from the edge, also 20. Alright, so we're kind of packing a bunch in there. Hole locations then. Wow, it looks really short. 40 between, oh, it was 60, so this is actually 72. Alright. So that was what I was looking for, is the 60 was from this line. And if we wanted to bring that over, we can pick up the grip and drag it back to the next point, get the 60 millimeters. All right, so that's looking better. Hole locations 4. I'm not worried about the pocket over here since it spans the axis of symmetry. Okay, 10 millimeters. First location is 10. And then there are 40 between the two holes. And then off of the edge or between the sides, 12 millimeters from the edge. All right, so made them horizontal but not equal. There we go. Okay, I think that's good enough to go ahead with the mirror. And since I didn't grab the center line in that mix, we'll pick it up as the axis of symmetry, mirror across, and put in the notch. Okay, so 30 by 18. Select, Control, Select, and make symmetric. Then we are 18 wide, we got that. From the edge then is 8. Alright, so let's go ahead and we'll raise that up. Extrude boss base, and the thickness of our part is 8 millimeters. Alright, so region 1, region 2. We'll get all of the geometry. Alright, for the end geometry then, I'm not as concerned for that that base. We're just going to copy over. Know that it was 12 millimeters. I can use that for the vertex for the end condition. Let's go ahead with a center line. And this comes up and intersects. And then we'll have the cylinder location. So outside is 24, inside is 14. And its location off of this edge is going to be 26. All right, 18 to the vertex. And then where this intersects is showing 14. All right, but there's not really, let's see, the radius of 5 millimeters. Well, if we bring that in and go vertical, it's showing 20 from the edges. So let's go ahead and mirror that over. connect the dots, and then we'll find those two intersection points and go to 20. All right, so a couple of choices. Manufacturer would almost rather have this come down tangent, and we'll go with the tangent arc. And 5 millimeters. Yeah, that doesn't look strange. All right, so to that vertex, no, not buying it. We'll get rid of that geometry and just come up vertical till it intersects. Put the 5 millimeters between the at the intersection. All right, so mirror the entities, and that'll get us started with the shape. So I want to show sketch 1, and my first feature, extrude. Don't know that it'll come all the way around. Nope, it's going to make a thin feature, so let's get all of that geometry in. And then this is going to be an up to vertex. We'll share that sketch. I can go ahead and hide that one. And distance from where we did the sketch plane, let's go ahead and show that sketch, is 37 millimeters back and then 62. So a couple of ways that we could do that is with the math. All right, so pretty much the ID. So if I were to offset this back 37 millimeters and then give it a distance of 62, well, that basically takes care of the math, except I got to get it going in the right direction. All right, so that gives it my shape. We'll double check the number. All right, so 62, 37. All right, so went the right way. Those all look pretty good. And then we can go ahead and hide that sketch. All right, everything with the fillets, 5 millimeters, 5 millimeters. Let's go into the fillet. All right, 10's a little bit big there. So we'll see what we can find in this mix. So connected to all of those. That would be pretty good, except for the two verticals. All right, I can go with that. And we just take those two out and add these two in. No, not the face, just the edges. And we'll go ahead and accept that. All right, so I mentioned the rib back to this geometry. If I were to open up a sketch, I just want to try this real quick. And we'll go with quadrant to the edge. Go into features, set the rib. So don't like the direction. Problem always exists with this curvature. Is it going to cooperate? And let's just go with a 6 millimeter rib. Direction is okay. And it finds the intersection and builds up the geometry. So that all looks good. So if you want to try the rib, you can put that in. Rib does not. Nope, it's not doing the offset. We'd have to make a plane if we wanted just a little bit of relief there. We'd have to make that plane in a millimeter or so to give it that relief. All right, so P492. Save that one back and go to the next one. Oh, our fun one. Okay, so every time I do this one, it has pretty much just resolved to do the layout sketch and get all the geometry in, and then start figuring out the depths and the whole segments, whole definitions. So layout sketch in this case is going to be, we're going to go metric. We'll go into the front plane, and the advantage of the layout is I don't have to be really clean or particular as long as the dimensions are accurate. So 60 and 100 to the edge. And the first angle will be out here. And we're given dimension of 20. So that's still connected. So I got to go from the line to the end point. All right, 30 from there to there. Is that going to work back then? All right, so let's get a few more lines in. Grab the midpoint, so that wasn't really what I wanted. So we'll get rid of the midpoint. 30 millimeters. And the thing to watch when I get rid of the midpoint is, did it stay coincident? Is it going to move off of that point? Which, yes, it does. So we'll put it back coincident. And then the base goes to 44. All right, so that one defined, and so we still don't have our angle. So from that point, let's go with this outside edge, bring it down, and this intersection gets a little strange as well. So over and back. And then we're going to end up with the 2 millimeters. And then that comes down. So we'll try to work through. All right, 2 millimeters on the edge. 3 millimeters on the end. And we'll just pick up these dimensions as we can get them figured out. All right, so set back to the point. Oh, that was on the top. Whoops. So let's get rid of the angles, and we'll just put in the verticals. And actually, no, that's going to make it confusing. We'll pull those out. Okay, so 3 millimeters. L on the keyboard. Okay, so that'll represent the step. All right, so the center, and then that would be the wall angling back. Okay, so don't have the notch in just yet. All right, so still the 30, 3 back to 2. All right, so the path that I took this time is not getting me to fully define very fast. So let's go up, over, and back for the T slot. And then all of that can be mirrored. Well, maybe not all of it. We'll go with the left to right. 10 millimeters on the opening. Looks like 5 millimeters. No, give it 20 millimeters on the overall. 4 millimeters on the height. And then 8 millimeters. Okay, position-wise, that went 10 to center line off of the hole, which is 7 millimeters, so we can go to 17 millimeters just to make that independent. And then that came back out. All right, so let's put in the parallel notch and another midpoint jumped in there. So don't know that that's midpoint. I'll go with coincident though. And didn't get parallel. Alright, so that depth looks like 6 millimeters. Okay. And then from that edge over, okay, so to the edge of the 2 millimeter, then that becomes 16 millimeter. All right, so if we can come up with, if I can find my angle, I should be in pretty good shape. All right, 30. Oh, it was 30 and 30. All right, so two of them right side by side. Couldn't see them both. So 30 and 30. All right, hole locations then. M7, M12, and yeah, for the geometry, no, I think that's okay. We'll just stay with these intersections. All right, so this one comes down, this one goes back, and we go into the loop because it's going to contact. Then we have the upper portion here. So diameter of 8 will give us a radius of 4. Height-wise will be 12. Oh, there was a little bit of a flat there. So those are probably going to stay merged. So one of them goes away. Oh no, that's still on the angle. Never mind. Let's undo it. Okay, so what I was looking at was the line that comes back to this intersection. And that's given it an angle from back to the point of 3 millimeters. And what do we do? Perpendicular? Nope. Okay, 12 in, 12 over. Okay, getting a little too messy there. Oh, and then it was 3 in. There we go. Invalid geometry. Okay, so that one went coincident to something that we didn't want it to. Okay, so those watch those relations. All right, should have one more depth. So 3 comes down at an angle. That's projected, or is that back to the intersection? Let's go to the intersection. All right, so we need a location. See if we can zoom up on this a little bit more, and details are a little fuzzy. Alright, so the 10 millimeters, 2.5 is the edge relief. Or no, 25 along that face. And it looks like it goes to the center, so if it stays parallel, we're going to go coincident. And merge the points. Okay, make sure that ends up parallel. And then the length across that face, 25 millimeters. Okay, got that. Still didn't get it to go fully defined, so we don't have an angle. Oh, the connection point. Let's go connect it to that 2 millimeter. And that looks a little more critical on the angle, but it gets us there. Alright, so let's go ahead and work with that and see how far we can get. And then we'll have to do a compare at some point and with previous versions of this model and see how close I get from version to version. Alright, so this is going to be the layout sketch, and we're going to not share the geometry. We're going to convert and trace over top of. Alright, so the outside, let's go with those and convert entities. Bring this down over and make the closed profile. Features extrude. Alright, for depth, I think we're going to go back and 56 millimeters. Okay, and then that step looked like 15. Alright, so 56 millimeters. And then we'll start on the front plane again, pick up our two edges, and then just connect the dots rather than dragging the converts back. Alright, so the offset for this is going to be to send it back from offset 15 millimeters. And then we'll go up to vertex and pick the end geometry. So let's double check. Alright, 15 millimeters. We can build in that shape. Alright, so the next shape, how do we want to do the undercut? You could start at the end, or we'll just break that in. Alright, so front plane. Okay, and the arc, just about as easy to convert. Alright, so this one had a setback. Let's see. And we picked it up somewhere. We had 15 millimeters there. And then it comes back 40 and 16. So instead of well, that would add up back up to the 56. So is it that step or that step that has the setback? Okay, 16 to the notch and then 40 across that face. So we're going to go up to vertex. Somehow, I want to say that previous versions I got that to set back somehow. See something different every time. Nice. Alright, so let's see if we can zoom up a little bit. If this face was 16, let's see, 16 and 16, 36 and 20. And since that's kind of hard to read, it would be handy if that was 16, because then I could pick up the bottom face directly on that geometry. Trace over the top. And that feature gets an extrude reverse direction, 20 millimeters. And there's the undercut coming up flush. Alright, to the outside geometry then, that generated all of the angle, generated all of this. And so we still have the steps to put in here. So from the top, open up the sketch, and need to be a little bit of an angle. And I want to make sure to overrun into the angle a little bit. Alright, so that was the outside. And make it coincident. It has a distance of 40. And then we can make the 2 or 3 millimeters across. Back up, and the 2 millimeter step. Alright, so that one becomes coincident with, and again the projection, nope. Let's see, direction wise we should be vertical. And then this one can be vertical here. Alright, since there's no real location that this has to go to, we'll pick up that next convenient edge. Alright, if we follow this back, that at least goes to the top of the arc, but we're only going down 22 and it went down 25, so we still need to be back 16 millimeters from the step. Okay, so that can extrude to a distance of 22. We'll go back into the solid, make sure that it's going the right way, and it's not. We'll reverse it. That'll give us the overhang. Okay. Alright, except for a few pieces of geometry, I think we're in pretty good shape. So let's go ahead and hide the layout. Go to the S key, pick up our geometry, M7 two places. Again, the assumption is without a depth callout, it's through. So 7 millimeters. Position. So distance of 12. And 7. So that doesn't look close to the perspective either, so what did I miss to center line? Yeah, maybe that wasn't center line, that was the other hole. So, 2015. That makes it even closer. So that's got to be a 25. Yep, that's going to be a 25. So 7, 12. Alright, so that's good. We'll pick that one up. Jump back in to our depth, 6 millimeters off of the edge. And that may be good for location, but it's not a great way to detail. 10 down. Alright, we'll go back to type, make sure that it said through all. Nope, had a blind in condition, so we'll go through all. And then back into the layout, the 17. which was my first try at it, goes to 25, and that looks better. So I can get it to a point where optically it looks like that has a setback, but no, that's a little strange. Alright, S key, we have an M12, 2 places. It almost shows like threads, but it's not called out with a by 1.25 or 1.75, so, and again, no depth, so through all. Alright, so position, and that was 10 millimeters off of this hole, so maybe, maybe not. Let's go back and look at the drawing. Yeah, there's still something in the stack up that I missed, so let's go back through it. Alright, so 25 millimeters to the center and to the hole. And then back and 7, so there's either, oh no, 10 millimeters to the, from the center line. So that 10 doesn't have anything to do with our geometry. Okay. So let's get this pointed over here. Update it to 25. That looks better. Double check that we were through all on the type. And go ahead and accept. And last piece of geometry is on the top. M12 through all. Position. Center definition. Looks like 20. Oops. Got ahead of it there. So let's just edit the sketch. 15 from the edge. And 28 would be center line, so I'll go 28. Alright, so still kind of a tough piece and a challenge, but certainly doable. We'll break out the utilities and the compare tool and see if this fits with the previous versions. Alright, P4-93.